Right. So the magic that I was talking about, Samriddhi, was that when I'm teaching here, right, you guys don't have to worry about taking notes or anything, because whatever I teach, that is getting recorded. It's only me and the board getting recorded. So don't have to worry about taking notes or forgetting anything, because everything is recorded, and I'll upload the video of the class after the class is done. So you can put your entire energy and focus on understanding and following the concepts. Yeah?
Yes.
Alright. So if you guys feel comfortable, turn on your video. If you don't, it's okay. My video will always be on. You guys have a choice of keeping a video on or not. Okay. So today we are starting a unit called Conic section. Now, what comes to your mind when I say that, okay, we'll learn conic section? What does it mean actually?
A cone.
A cone. Okay. Samriddhi, what comes to your mind, beta?
Circles.
Little louder.
Circles.
Circles. Okay. Arush, what pops up in your mind when I say conic section? What does it actually mean? What I'm trying to navigate you guys towards? Yes, Vishal.
Like circles, parabolas, and eclipse, and all those things.
Okay. And those things include what else? So you talked about circles, parabolas, and eclipse. What is one more thing? Searching it up. Okay. So here, some of the kids. Okay, you guys are all kids. Okay, Samriddhi, since this is your first class, so you will probably get surprised that I'm already a high schooler and how come this old man is calling me kids. You guys all like kids for me. Okay, that's how I treat you guys. So some of the kids here saying that probably they have the luxury of searching it up. Regardless, let's kind of break our head a little bit. I'm sure you guys have not seen this. This is pretty much an Indian thing. Okay, when we grew up, when we go in trains, okay, we'll buy something, some dry snacks. What they will do is they will fold a paper like this and put the peanuts or the spicy, what do you call, chips or puffed rice, right, mixed with a lot of spices into it, and they will put it in this one. Okay, so the time when we were enjoying these spicy interesting snacks, we never knew that this is a foundation for one concept that we learn, that is called conic section. So this is a cone actually. I mean, I know this is not a perfect ideal cone, but this is how a cone looks like. Yeah, you guys will call it a cone, right? Or you'll call it something else? Cone. Now, when you cut this cone in different angles using different sections, different planes, that is when you will come across different shapes that you guys were talking about. It could be a circle, it could be ellipse, it could be parabola, it could be something that you guys did not talk about, that is called hyperbola. And you must be thinking that, okay, you showed us a can for holding snacks and you're talking about all these fancy terms. Now this is my cone. When I take sections of it, let's say this is my plane, okay? Let's say this is, my hand is very sharp and I try cutting it, okay? So what I will do is, assuming my hand is very sharp, I cut this. Just look at the circumference of this. Is this, I mean, I know my cutting skills are not that great, but if I would have done a better job, it would have looked like a perfect circle. So when you cut a section with a horizontal plane, the side, the view that you will get here after cutting it, that will be a circle. So now let's visualize this here. This is your cone. Okay. And this is called an axis, which kind of tells you that okay, this whole cone is symmetric around this vertical line, which is the axis. So when you have a plane which is perpendicular to this axis that you are seeing here, you will see that this portion that comes out from this is a perfect circle. That's what I was trying to demonstrate with my unskilled attempt.
So
Yeah.
like when you cut off the top edge of the,
Yeah, top edge or anywhere. You can cut here.
so you just cut somewhere in the middle.
Yeah, just make sure that this plane is perpendicular to this axis. You can cut it here, you can cut it here, you can cut it here, wherever you cut
So
it.
you horizontally cut it somewhere in the middle of it.
Horizontally or basically cut with a plane which is perpendicular to this vertical axis. Or axis of symmetry, whatever you call it. Is that making sense so far? Samriddhi, Vishal?
Yes.
Now, imagine your plane with which you are trying to dissect this is not perpendicular to this axis. Not perpendicular to this axis, meaning it's like this. Then when you look at this shape, okay, this will look like an ellipse. So you have the same cone, depending on how you are dissecting it or cutting it, using a plane, you got circle and you got ellipse. Now, flip that plane perpendicular, meaning now you try cutting this or slicing this cone with a plane like this, which is parallel to this axis of symmetry. And then when you see this part, this will look like a U or a U upside down, which is nothing but your parabola. Now imagine you having two cones like a bell here. Yeah? And then your plane is cutting or slicing it perpendicularly. The shape that you will see here will be like this, which is called hyperbola. So, I mean, we have been learning about circles, rectangles, squares, trapezoid, kite, rhombus, whatnot. But the origin of that is your cone. If you have a cone, depending on how you are dissecting it, what plane you are using for cutting it into pieces, that gives birth to all these four shapes: circle, ellipse, parabola, hyperbola. And that is why all these things together are called conic sections, because when you are taking a section of a cone, these shapes come into existence. Does it make sense? Little bit? Samriddhi, Arush, Vishal, Devik? Yeah?
Yeah.
So basically these are together called conic sections because these are coming into existence due to section of the cone. Okay. Now, before we dive deeper into the conic sections, there are certain basic concepts that we need to kind of refresh so that when we get inside conic sections, our base around whatever we know with respect to these shapes don't get diluted. So there are a couple of things that I would want you guys to recall from what you have learned before, and if you have not come across this in the past, we will double click on that. But then this conic section is a very, very important, and it might sound little tricky concept to begin with at times. Okay? Now, I'm hoping, I'm assuming, I'm guessing everybody is super clear about Pythagorean theorem. No doubt. A square plus B square equal to C square. Is everybody clear? And this holds true when you're talking about a right angle triangle. This is A and this is B. These are two sides making 90 degree, and C is your hypotenuse. So A square plus B square equal to C square. Everybody is clear, right? Samriddhi?
Yes.
Yeah. And yeah, Vishal, everybody here, right? And we have seen how this comes into existence, why this formula is even true. We have validated that in the past. So if anybody again gets that question in mind, how come this formula is to be believed, we can double click on that, but not now. We'll come to this. Now you will say, why do we even have to worry about Pythagorean theorem? This is actually a base for this cone, for your cone. If you want to imagine or visualize your cone, think about it. See, this is the right angle triangle, okay? Which is see, this is a circle here, which keeps on becoming narrow and narrow, and here we set a point. But if you look at it carefully, can you guys see the board, okay? Samriddhi and Vishal?
I can see.
Yeah, okay. So when you look at it carefully, what you are seeing is, let me use a different color so that you guys can differentiate. If you look at this cone carefully, this is a right angle triangle. If you rotate it 360 degrees, that's what forms the cone, isn't it? Yeah. So, I don't have something that I wanted to show you guys. Like you would have seen a toy, like a stick, and then you have a triangle attached to it, and when you rotate it, it'll look like a cone. So basically, if you look at this carefully, this is your right angle triangle which is rotated. Hey Tanvi, you got late by 7-8 minutes, so you missed something, but I'll come back to that. Okay? So today we are covering conic sections, okay? And what we covered was a cone is this. If I take different sections of a cone, meaning use a knife, blade, or anything that is sharp enough, cut it with different sections, that is what gives birth to shapes like circles, ellipse, parabola, and hyperbola. Okay. When you are cutting it with a horizontal section, horizontal, and not just section, horizontal plane, what you see here is nothing but a circle. If you tilt that plane little bit, what you can see and then cut it, you will see an ellipse. If you cut it this way using that plane, you will see this edge that you will see will be your parabola. If you have two cones facing each other upside down and then you use a plane for cutting it, what you will see here is going to be looking like this. So this is a hyperbola. So that's why we call this whole chapter as conic section, or whole unit. We have just started. This is a little big enough unit, which will take a couple of classes for us. But the underlying principle is that all the shapes like circles, ellipse, parabola and hyperbola that you see, that originates from cone. When you cut the cone using different planes, different alignment, different angles, that is when you come across these shapes. That's why these are all together called conic sections. By bisecting a cone or dissecting a cone gives you these shapes. That's why it's called conic sections. Is that a good starting point, Tanvi, for you? Tanvi, you have to say yes to me, not to the mute button.
Oh, sorry, sir.
Yeah. No, but you got that, right? I mean, the basic principle why we call it conic section?
Yeah.
Okay. So let's move on. So now what we are doing is, conic sections as a unit would be a little tricky one. You will probably need to have that background in place whatever we know, that we have to recollect and then go deeper into the conic sections. So first thing I was checking with everybody is, we all know this theorem that is called Pythagorean theorem, okay, which is relating to a right angle triangle, which says if these A and B are two sides making that 90 degree in a right angle triangle and C is the hypotenuse, A square plus B is equal to C square. That's a Pythagorean theorem. And why we are talking about Pythagorean theorem? Because that gives the birth to this whole cone itself. If that's what I was explaining when you joined Tanvi. So here, this is, if you look at it carefully, this is a right angle triangle, and you take that right angle triangle and rotate it with 360 degree, and you will see this cone. Like when you see a fan rotating, it gives you a feel of a circle. Similarly, when you rotate this right angle triangle by 360 degree, it makes the cone. Is that okay? Yeah? Alright, so we'll come to this. Now, this was the first thing. So Pythagorean theorem is something that you all have to recall before we go deeper into conic sections. This is one. Now the second one. Is everybody able to recall what is a circle theorem or circle formula, standard circle formula? Everybody here. Circle formula or circle theorem. Since we are going to deal with circle in this chapter, this unit, do you guys remember the circle formula or circle theorem? Samriddhi, Tanvi, Vishal? Yeah? Okay. Let me write it down for you guys so that if I am saying a different name, at least the theorem will help you recall it. Circle theorem says x square plus y square equal to r square, where the origin of the circle is at 0, 0. Or x minus a square plus y minus b square equal to r square, where r is the radius and a comma b are the coordinates of the center. This is a circle theorem. Everybody remembers this? Do you guys remember the formula for ellipse? Anybody? No? Tanvi, Samriddhi, Vishal? And Samriddhi, just for you to be aware, why I am giving the formulas here, I'm not a big fan of remembering formulas, okay? So any and every formula that we come across, I try to prove that. Since this is your first class, so you have not seen me proving that. When you join the SAT class, you will come across that, and when we come back to this formula, we'll again prove it, okay? But so this is the equation of circle. Now, equation of ellipse. Ellipse is a stepchild of circle, or circle is a stepchild of ellipse, whichever way you want to remember that. In a layman's term, it is x by a square plus y over b square I'm just trying to recall. I think this is yeah. Okay, forget about the ellipse formula. I don't remember that. I don't want to remember that right now. Okay, we'll come back to this. We'll come back to this when we come to this part. So, to begin with, one thing is remembering the circle formula and then the Pythagorean theorem. As long as you guys remember that, it's okay. Now, was that an abrupt end, Samriddhi? I was wanting to talk to you guys about this ellipse formula, but I'm not talking about that. But it's okay, right? Are you guys worried? Not worried. We'll come back to that. Okay. But what I was trying to say was that if you look at a circle and ellipse, what is the difference between these two? Here, in case of a circle, every point from origin to the perimeter is same, which is radius. In case of ellipse, what you see is, you see a minor radius and a major radius. They call minor radii or major radii. Okay. So this is called the major radius, and this is called the minor radius. I mean, so when we look at the formula for circle, right, you will see that x squared plus, assuming that the origin is at 0, 0. Here also, let's say the origin at 0, 0. It becomes x squared by minor radius. I'm trying to recall the formula. Okay.
Isn't A area? Or,
Say that again.
oh, wait, no, A is minor radius and B is major radius, right?
X squared by, yeah, okay.
And
X
area-
plus y squared by b squared equal to 1. Yeah.
And area is pi B. Or-
That we can figure out. So this is a formula for this one. Okay. So okay, this is now here when your major and minor radius are the same, this will become x squared by a squared plus y squared by b squared. So let's say both are same. So this becomes x squared by r squared, y squared by r squared equal to 1. So this becomes x squared plus y squared times r squared. Sorry, x squared plus y squared equal to r squared basically. So okay, now I recall. Good, my age is still with me. So now let's just look at the concept one more time and then we'll move on. So basically what I was trying to say was, imagine this being your starting point, which is called ellipse. Ellipse has two radius, one is called major radius, one is called minor radius. The equation for ellipse is x squared by a squared equal plus y squared over b squared equal to 1. And how is that even arrived at? We'll talk about it later. Yeah.
A and B are the radius, right?
A and B are the major and minor radius. Okay. And we'll muddle the water when we come to ellipse. Okay. So don't worry about it. I'm just trying to recall the formula. Now here A is the major radius, B is the minor radius. So x squared by a squared plus y squared by b squared equal to 1. And there are different flavors of it. When it is, when the major radius is along y-axis, then this thing changes. Okay. So for now, for the simplest form, this is the formula. Now, if you think about it, your major and minor radiuses are different. That's why it is ellipse. Imagine this squeezes and becomes a circle. And here, your minor and major radius are same. This and this are same. You can apply the same formula here. X squared by r squared, minor radius, plus y squared by r squared, major radius, both are same, equal to 1. What it will become? X squared plus y squared by r squared equal to 1, or it becomes x squared plus y squared equal to r squared. So basically, both can be related as far as the formula is concerned. Okay, meaning this is an ellipse where your minor and major radiuses are different. When they become the same, it becomes a circle, and the same formula applies. So anybody and everybody in the class, including me, who was not able to recall the formula of an ellipse, this is how you can relate and recall. I have not seen the formula of ellipse for last at least 6 months. I had forgotten. But then when I was able to relate it, I could find the formula real quick. Is that okay, everybody? Tanvi, Samriddhi, Vishal, Davik. Yeah? And don't be shy. If you have to say yes, unmute yourself and say yes. This thumbs up, thumb down is perfectly fine. But when you say something, you can say it loud and clear. Okay? And if it's not clear, I don't mind explaining the concept 5 times, because I strongly believe that I don't do a good job always. Okay, sometimes if I'm not doing great, I will correct it and then redo the things. Okay. All right. So we looked at what is conic section, how circles, ellipse, parabola, and hyperbola are called, and how and why they are called conic sections conceptually. So tomorrow, I mean, we don't really have to worry about why we are learning about circles when you talk about conic sections, why we're not talking about cones, why we're talking about circles, right? So at least that correlation we have seen. And then we looked at the basic equation for circle and ellipse. Now, parabola. Can anybody tell me what is the formula for a parabola that you guys use mostly?
X squared plus b x. No, x squared plus x plus.
Complete your chain of thought. It's okay.
Okay. X squared. This is x squared, right? The
Okay.
parent function or the base formula?
Any formula, any standard formula
Standard form is ax squared plus bx plus
equals
y.
equals y. So this is the standard form of a quantity equation, ax squared plus bx plus c. Equate that to y. This is a standard form of a equation of a parabola. Meaning, on one side, one of the variable in the form of a square gives you a parabola. Only one of the variable. Now let's look at some interesting aspect of it. What I'm saying is y equal to ax squared plus bx plus c is a parabola. X equal to, let's say, ay squared plus by plus c is also a equation of parabola, because only one of the variable is a square. Only one of the variable is squared. The time I say x squared equal to y squared plus 8, I am putting two parabolas together. This parabola and this parabola came together and makes a circle. So you cannot have an equation for a parabola where both the variables have the maximum power of 2. Yeah? Vishal, Samriddhi, Tanvi.
Yeah.
Making sense? So this is the standard form of a parabola. But there is one more property, one more quality of parabola that we need to be aware of. And that will be a very important concept that we will talk about in conic section. I'm not going into depth of parabola for now, but let me ask this question real quick. So Samriddhi, Tanvi, Vishal has dealt with parabola with me for some time, but for Tanvi and Samriddhi, how comfortable are you guys with parabola concepts? And you guys as well? Okay? Not okay?
I don't know. I have to be like tested on this.
Okay.
Yeah, I don't know how good I am at it.
So Samriddhi, I mean, if I ask you, how comfortable are you with parabola concepts? And be honest, brother, it's okay. I mean, that's why I'm here.
I think I can do most.
You can do most of it?
Yeah.
How about you, Tanvi?
Yeah, same. I can do most of it.
Okay. So again, whoever is in the SAT class, I will make sure that you guys are getting an opportunity to muddle the water enough with parabola when we come to parabola concepts. But since we are talking about conic sections, I'm not going into depth of it. But there is one concept of focus and directrix. Let me see if I'm using the term correctly. Directrix. Yeah, focus and directrix. So this is one interesting property of a parabola that you would want to be aware of. Let's say I have a parabola. Let's say I have a quadratic equation that plots a parabola. Okay? Like this. And I have a line. I have a line here let's say y equal to 2. Okay, this is 1, this is 2. But before I start blabbering, do you guys know what is directrix and focus? Do you already know, or I'm starting afresh?
Wait, what?
Focus and directrix.
Yeah, I know when algebra 2. It's just if there's a line, I think focus is P or something, and it's just distance between the line and the problem.
I think algebra 2 too. I guess it's talking.
That's one unit.
Anybody being aware of directrix and focus beforehand? No? Okay.
What did you say?
Focus and directrix in a parabola.
This would be the focus. And this would be 1.
Okay. So Vishal is thinking that makes me think as well. So okay. So this is the concept. Let's come to this. Okay, now focus on the teacher. Now focus on the teacher. Coming back here. So you have a parabola, let's say. This is a parabola. And I'm just picking it up. The equation of this parabola is ax squared plus bx plus c. Okay? Yeah? This is my equation, standard form, which is plotting this one. A and b, c values we'll figure out later. This is plotting this parabola for me. Okay? This is a line. Let's say y equals 2. I'm calling this line as a directrix. Okay? I just felt like calling it directrix, I call it directrix. Okay? And I have a point here, let's say I call it F or P, whatever I will say. Okay? And its coordinates are, let's say, A comma B. Let me not confuse you guys with this one. 5x plus 2x, 5 square plus 2x plus 7. This is my equation. I am saying I have a point F, which I am calling as a focus, which has coordinates A comma B, x and y coordinates A comma B. Okay. And this line y equal to 2 is my directrix. I am calling it directrix. This is a very interesting property of a parabola, which says that if you have a directrix, let me call it y equal to h. Okay? If you have a directrix y equal to h and a focus as f, how they are related is, any point you pick on the parabola, the distance between this point and this point to the directrix, the perpendicular distance between any point of the parabola to the focus and the perpendicular distance between this point to the directrix will be the same.
Oh, like the radius of the
Something relatable to, on the lines of radius. So what it means is, if I take this point, the distance between these 2 points and the distance from here to the perpendicular distance with the directrix will be the same. So this length and this length will be the same. This length and this length will be the same. Let's say I pick up this point. So distance from the focus to this point, whatever is the absolute distance, this distance and distance from here to the directrix, the perpendicular distance, these two will be the same. Yep.
Will the focus always be like above or under the parabola, depending on like which way it's oriented?
Depends. So basically, parabola doesn't have a fixed length, right? I mean, for the sake of our convenience.
No, I mean like under the what is it? Like, will it be like under the what is it? I forgot. Like the top, like the topmost or bottommost part. I forgot the term.
Vertex.
Yeah.
So it depends. I mean, I don't think I have a theory which I can use and say, hey, the focus has to be just above the vertex or it has to be
Not
behind.
like exactly, but like generally above or under.
It will be mostly above the vertex only. It will be above. The vertex is always your bottommost point.
So what if it's like vertically turned upside down?
If it's upside down, it will be inside this.
Oh, okay. So it's always like under or above.
Inside the problem, I mean, practically speaking, so far I've dealt with, let's say, 50 problems. I have always seen this being inside.
Okay.
Think of it, okay, if I'm talking about this point, see, here to here, and then my, let's say my directrix is here. You will see that this distance is not looking optically correct. Same. If I pick up this point, here to, let's say this point, okay, sorry, this point to this one distance and this point to this one distance doesn't look optically matching, right? So mostly you will find this in a symmetry such that it abides by that thing. It will be inside the parabola 99.99% cases, unless mathematically somebody comes up with a very different solution for this. So, okay, so now directrix and focus. Are you guys at least conceptually clear about it before I go deeper into it? Samriddhi, Vishal, Tanvi.
What did you say?
No, I'm just asking if directrix and focus, is that clear to you conceptually? I mean, we have not done the mathematical side of it, but conceptually, are you guys clear?
A little bit.
A little bit?
Yes.
Let me just do it one last time, okay? Because I don't feel confident if I don't hear a confident yes from you guys, okay? And I'm okay, I'm not in a hurry. I don't want to finish everything and say, we did everything. What my kids know? Nothing. Now, what I'm saying is, I have a coordinate plane, I have a parabola. Any line, I'm calling this as y equal to k, okay, as directrix, and a point F with the coordinates a comma b as a focus. So the property of this focus and directrix is such that focus is a point and directrix is a line, such that, I mean against a parabola, such that any point you pick on the parabola, any point, the distance from focus to that point on the parabola and the perpendicular distance from this point to the directrix is same. Am I being clear? So if I am saying this is my focus and this is my directrix, I picked up this point, the perpendicular distance from this to this and this to this will be the same. So this length and this length will be the same. I pick up another point, focus to this point distance and this point to perpendicular distance with the directrix will be the same. Does it sound okay?
Yes.
Okay. Tanvi, Vishal, everybody? Now let's, storytelling is done. Now let's get to the math part of it. So, what we'll do is, based on the focus and directrix, we'll try to derive the equation of the parabola. This is a kind of a question that you guys will also come across. Saying, okay, this is the coordinates of the focus and this is the directrix, find out the equation of the parabola. So you'll have to derive it. Or you have a parabola and you have a directrix, find out the focus. Whichever way. So let's say this is my parabola and I don't know the equation of the parabola. I know in the best case scenario it will be a quadratic equation on one side and a variable on the other side. But I don't know. So let's say this is my focus. F A comma B. Okay? This is my coordinates. And let's say this is my directrix, which is y equal to h. Directrix has to be a straight line. It has to be a linear equation actually. So y equal to h. Now, by the definition of focus and directrix, what we know is, let's say if I pick this point, x comma y. The distance from here to here and distance from here to here will be the same. Yeah? What is this length? Can you guys tell me? This is x comma y, and this is y equal to h. What is the length of the perpendicular distance of this? I mean the length of this line.
Perpendicular.
I mean this length of this line. This is a perpendicular distance from this point to this directrix. So, can you guys tell me what will be the length of this line segment?
H plus y.
Or y minus h. This point's coordinates are x comma y. So this length from here to this is x-axis, this is y-axis. So this whole length from here to here is y. This length is h. So this will be y minus h. Yeah. Are you guys with me so far? Tanvi, Samriddhi, Vishal?
Yes.
Okay. Now we got this length. By the definition we know this length will be equal to this length. Correct? Now let's look at what is this length. This, how much? Y minus h.
Yeah, because you're that.
No, I'm saying based on these two, you have 2 points. You have 2 points on the coordinate plane. If you have to find out this length, how much that would be?
But no, you
Now-
because you said that line, like that, the one, yeah. If you like extend it, you said that's h, like cursive h. So that would be x times h.
X minus h, but I'm saying, imagine that this is not known to you. If you were just knowing these 2 points, the length of this line. Now recall your uncle, my uncle, everybody's uncle, Mr. Pythagoras. You have to find out this length, and this is your hypotenuse of this right angle triangle. So this distance is, see, look at this, from here to this point. What is this length? This is A. Here to this point. What is the length? This is B, y coordinate of this point. X and y. So what is this length? Here to here is X. Here to here is Y. So this length is what? X minus A. X minus A. This length. What is this length? This whole thing is Y minus B. So this is Y minus B. What does Pythagoras' uncle say? What did he say before he died? What? X squared plus Y minus B squared equal to this length. This length. Let's say this length I don't know. I'll call it B. My name. Oh no, not B. B. We already have a B here. Let's pick up Tanvi's name. Okay. So let's say this length here to here is T. Okay. So this square plus this square will be equal to T square. So X minus A square is this length. Y minus B is this length. This is not Y minus B. This is B minus Y. Sorry, not Y. This is B and this is Y. So B minus Y whole square equal to T square. I have given the name T using the first character of Tanvi's name. Okay. So this length is T. So X. Okay. So why I'm messing it up? This whole thing is A. This much is A. X. So X A minus X squared. This whole thing is B, and this much is Y. So it's B minus Y squared equal to T squared. Now this T squared, by the definition, we know that is equal to this, which is Y minus H. Yep. Yeah. This is circle. I'm not calling the circle formula right now, because this is my Pythagorean theorem, which says that if I have a right angle triangle, the sides making that right angle triangle, square of this side plus square of this side will be equal to square of the hypotenuse. So I'm not treating this as a circle formula yet. I'm treating this as a Pythagorean theorem. Two sides making 90 degrees, square of the sum of the squares of the two sides will be equal to square of the hypotenuse. And this hypotenuse is equal to this as per the definition of focus and directrix. Are you guys with me?
Yeah.
Tanvi? And Samriddhi, I know I'm kind of trying to put you on the spot because this is your first class. That is just an attempt from my side to make sure that you are able to follow me, okay? Because everybody else has been with me for some time, so they probably have figured out how to deal with me. You are still working on it, so that's what I'm asking, okay? So don't get me wrong. I'm not trying to question anybody in particular, but I'm just trying to make sure that everybody is able to follow what I'm talking about. Yeah.
Yeah.
Okay, so now we got this one. Let's simplify this. A minus x squared, that is a minus b whole square, is a squared minus 2ab, so a and b, plus b squared, that is x squared, plus b minus y whole square, a minus b whole square kind of a thing. So it becomes b squared plus y squared minus 2by is equal to y minus h whole square, that is y square minus 2yh plus h square. Let's see if we have a way to cancel out certain things. So we have a y square this side and y square this side. These two can be cancelled out. What we are left with is a square minus, okay, so let me write it down here. A square minus 2ax plus x squared plus b squared minus 2by equal to h squared minus 2yh. So what we are trying to do ultimately is find the relationship between x and y, because x and y will be the coordinate of any and every point on the parabola which will satisfy this whole situation, right? So here what we'll do is we'll keep all the y thing on one side. So what all we have here? This y square we cancel, so we only have 2by here, okay, and any other y that you see. Okay, so it becomes like this. So let this be a minus x whole squared plus b, here you can take b out, it becomes b minus 2, or no, I'm just thinking, okay, what all we can combine, okay, let's do one thing, let's get all the y's on one side. So this a squared minus 2ax plus x squared plus b squared and minus h squared. So I'm getting all things on one side and keep only y on the other side. So 2by minus 2yh. So this is a minus x whole squared plus b minus h whole squared, b square minus h square equal to, here if you take 2y out, you have b minus h. Okay, yeah, I think I'm getting there now. So from this one, if you just keep y on this side, that means 2b minus h you will divide with everything with. So a minus x squared by 2 into b minus h plus b square minus h square, that will be b plus h into b minus h divided by 2b minus h. So yeah, this b minus h and this b minus h will cancel out. So your equation becomes y equals this a minus x whole square over 2b minus h plus b plus h over 2. Now you will say, how would we remember this kind of a formula? And I have no clue. I don't think I have any way to remember this formula. I mean, I just derived it. So here's the thing. You don't have to worry about this kind of a thing. you don't have to worry about deriving this formula. First, let's go back to understand what did we do in the first place. We just looked at the concept of, all that I did here was a drama or circus that I was doing on the board to get you guys confused. Don't even look at it. What I'm trying to say is, as long as you know what is focus and what is directrix, as long as you know the concepts, you can still do this without any problem. You know that, okay, focus and directrix. If I know directrix equals something as a like equation of the line, meaning I know this height, which is h, then what I can do is I can assume x and y to be a point on the parabola, find out this distance and match that with this distance. That should be enough for us to be able to apply this. If you are able to remember this formula, that will be magical. I don't think I memorized this formula. I mean, I would be able to remember this formula, okay? But if you are able to do it, nothing like it. But I would not prescribe that. So net what we did was, we picked up the coordinates of the focus, and this distance we found it out. So now, from a coordinate plane perspective, right, this is something that you would always know, or that you would need to, or that you would end up memorizing actually. If you have 2 points A and B, okay, this has coordinates x1, y1, and this has coordinates x2, y2. If you have to find out this distance between the 2 points, it will be y2 minus y1 square plus x2 minus x1 square root of that. That will be a length of a distance between any 2 points. Meaning, look at this. What is x2 minus x1? This is x2 here to here. This is x1. x2 minus x1 gives you this length. This is y2. This is y1. So y2 minus y1 gives you this length. So this square plus this square will be equal to this square. Since you are trying to find out this absolute length, that will be square root of this. Radius or distance, whatever you call it. So any 2 points that you are given, you can find out the absolute distance between the two using this formula by visualizing this right angle triangle. Once you find out this length and this length have to be the same. And you will just apply, say that, okay, let's say this point xy is on parabola, and then you find out, put this value, we'll solve few problems, okay? And then that will probably, give us little more clarity with respect to this. So then you will say from xy to this point's distance will be equal to this height. And then we should be able to apply that to derive the formula for the parabola. Or the equation for the parabola. So whatever I said, as long as you remember what is focus and what is directrix, you will be able to use this concept to solve a problem. Let's try solving one problem, okay? Because otherwise you guys will think that this guy at this age only talks, deceives and runs away. Let's look at the concepts here. Let's look at one of the questions here, okay? It says, write the equation of a parabola with a focus at minus 4, 3, okay? And the directrix at y equal to 5. You have to write the equation of the parabola. What would go in your mind from an approach point of view? I mean, I will solve it, but I just want to see which way you guys are thinking. Yeah.
I'd use the midpoint formula, and then I just plug that point into the into the parabola equation, and then just get it from there.
And you have to derive a parabola equation actually. How would you do it? So first thing is, I came back from work at around 6:15. I did not bother to get ready for the class. I mean, I don't believe in beautifying myself before the class. I did not do that. All that is a blabber. What I'm saying is you have to get your hands dirty. Now, if I have a situation like this, we have to solve this problem, okay? Let me give you guys a simple breakdown of this. For the sake of simplicity, I will assume that my parabola is like this. I'm just not worrying about it for now, okay? Graphing the parabola is not important for us. Deriving the equation for a parabola is what the ask is, right? So even if I draw a wrong thing, it's okay. What it says is, focus is at minus 4, 3. So maybe this is a point. Focus minus 4, 3. I mean, this doesn't look like the case, right? X is minus 4. Okay. Let me sound a little more reasonably right.
Second quadrant.
Yeah. So my focus is minus 4, 3. Now at least you have some respect for me. I'm not putting in the first quadrant and saying minus 4, 3, right? So this is my focus. And directrix is at y equal to 5. So let's say this is 5, 10, 15, 20, whatever. Okay. So directrix is at 5, y equal to 5. See, now again I'm making a mistake. Y equal to 5 I'm saying, but if this is y equal to 5, how come this y is above this? So basically my directrix is somewhere above this, okay? Yeah. So this is y 4 minus 4 comma 3 and this is y equal to 5. This is my directrix. And there's no theory that says directrix has to be above or below, okay? So this is my directrix. If I pick any point here, let's say x comma y, here to here this distance will be equal to this distance, correct? Now how much is this distance? Perpendicular distance from focus to the directrix, how much is that? 2. See, this distance is 5 and this point focus coordinates are minus 4 comma 3. So this is 3 and this is 5. So 5 minus 3, this is 2. Yep. So this length is 2. Now from here to here the perpendicular distance. So x minus 4, that will become x plus 4. This square plus y minus 3 square will be equal to 2 square. Because this length has to be equal to this length. As per the definition of, oops, my bad. This will be equal to this length, sorry, my bad. So this distance from here to here, this distance will be equal to this length, which is nothing but, this is y and this is 5. Yep. This point coordinates are y and this is 5. Okay. So what does focus and directrix say? This distance from focus to this point and from here to the perpendicular distance with the directrix is equal. So here to here, this length is this, 2 points distance is this square plus this square will be equal to this length square based on the Pythagorean theorem. If you visualize this like a right angle triangle, okay? So this length is, this square will be equal to this length square, and this length is nothing but, this is y and this is 5. So I'm saying that this distance is, okay, if you think that this is looking opposite, so 5 is above and y is below, so 5 minus y square. That is also the same. Yep. Am I getting you guys confused? So now this is x plus 4. So this was the length. X plus 4, x minus 4, that becomes x plus 4. This square plus y minus 3 square, this gives me the absolute length. Square of the absolute length will be equal to square of the absolute length here. Now you have this equation, you can break it down. Simplify this becomes x square plus 8x plus 16 plus y square minus 6y plus 9 equals y square plus 5 square is 25 minus 10y. Now y square you can knock off. You will have one side which will have only y with power 1 and other side with x terms with maximum power as 2, which is a parabola equation. So even without memorizing the formula that I had spent 15 minutes to show you guys, even without knowing that formula, we are able to derive it based on the focus and directrix. Is that looking reasonably okay, Samriddhi, Tanvi, Vishal? Or I got you guys confused more? Samriddhi, you were saying something, Vira. Was it clear? I'm sorry, Vira?
Yes.
Clear?
It was clear.
Okay, so what I'm saying, so the biggest relief for today is the 15 minutes of your life that I wasted initially to derive that formula, that is not needed. We derive that formula. If somebody believes in memorizing things, you are more than welcome to memorize it. Once the video is uploaded, you will be able to see that formula. But there is no reason or motivation for doing it. That formula I showed was primarily to give you guys the idea that if you have a parabola, if you have a focus, if you have a directrix, what it means is any point in the parabola, the vertical distance from this point to this point and this point to the directrix will be the same. And that is exactly what we applied here by using the distance formula and the concept behind focus and directrix to derive the equation for the parabola. This might not take more than 2 minutes for you guys when you practice some more problems, but memorizing the formula might give you a scare. If you miss one term, life becomes more interesting. So that's the reason why I don't prescribe the memorizing formulas. But there are some formulas that you'll end up memorizing, obviously, but not with a dedicated effort to memorize the formulas only. Does it make sense? Then that being said, I will let you guys go have fun. I'll upload the video of the class, and if you guys want, I can send you guys. Actually, you guys don't have to wait for any assignment. I don't give assignment to the grown-up kids like you guys. Go to Khan Academy, start unit 13, go to Conic sections. I mean, that's what is unit 13. If you see some other things, search for Conic section. Do the first one which says deriving the equation for a parabola using focus and directrix. And you'll find 5-10 problems. Try solving them. If you're able to solve them, wonderful. If you're not able to solve them, catch hold of me. I will explain one more time. Yep. With that being said, have fun. Talk to you guys on Saturday, Sunday. Yep.
Bye. Thank you.
Alright, bye-bye.
You.
Bye-bye. Samriddhi, do I speak very fast or it's okay?
Oh no, it's okay.
Okay. Alright then. Good night, beta.